So our physics project is about the principles of energy with the experiment of bouncing a ball. So just to give an experiment introduction, our experiment covers the concepts of potential and kinetic energy along with the conservation of energy with the use of bouncing a volleyball. We basically bounce this volleyball to find how determining the potential and kinetic energy of the balls could predict the height and compare this to the experimental height. The way we did this was through determining the velocity right after the bounce, which would be the initial kinetic energy, which then we would use to find the maximum predicted height through energy equations and the conservation of energy, as this should be equal to the potential energy at the height of the bounce. So just to talk about the principles of energy and conservation, there's the diagram on the left kind of shows what kinetic and potential energy is. So potential energy is when the biker's at the top of the mountain because there is a delta y, a height that he's on top of, and this potential energy will get transferred to kinetic energy when motion occurs. And that's why the equation for kinetic energy includes velocity, because when there is a velocity, the potential energy is being transferred to kinetic energy. Now, the reason why we're able to do this experiment is due to the conservation of energy, because energy is conserved in an isolated system. So due to this, what we're able to do is set the initial kinetic energy right after the bounce, find the velocity of that, and set that equal to the potential energy at the height of the first bounce. So using this, we can derive the equation kinetic energy, the initial kinetic energy, Ki, is equal to the final potential energy, UGF. So here is the video that we did with the volleyball.
Go.
So from the video, we used the graphical analysis and we were able to find the velocity versus time graph. And as you can see, as marked on the graph, the velocity right after the bounce is 4.00 meters per second. So this is what we're going to use for the kinetic energy equation. So now to find the bounce height, just to give a background on this equation that we set up, this is the conservation of energy equation. The left side is the UGF, which is the final potential energy, and the right side is the initial kinetic energy. So as you can see, the VIY is the initial velocity after the bounce in the y direction. The m is the mass of the volleyball, which can be canceled out of the equation due to it being on the numerator and denominator. The g is the gravitational constant, which is 9.8 meters per second squared. And the delta y is the change in height, which we're trying to find. So as you can see, we solved for it on the right, and we got the delta y to be 0.816 meters, which is the height of the bounce. Now, we also did the position versus time graph, and this is the experimental height. So this is what we were able to find from the graphical analysis. And as you can see, the actual height was 0.810 meters. You can see it's marked on the last point on the graph. So just to give a conclusion, the predicted height using the conservation of energy principle, which was UGF equal to Ki, was 0.816 meters. The experimental height that we determined from the actual bounce was 0.810 meters. So you can see that these values are very similar to each other, only differing by 0.006 meters, which displays that the ideas of conservation of energy can be applied to predicting the height of the bounce as long as you know the initial velocity.